Develop schedule is the sixth process, and it analyzes activity sequences, durations, resource requirements, and schedule constraints to create the project schedule model. The key benefit of this process is that by entering schedule activities, durations, resources, resource availabilities, and logical relationships into the scheduling tool, it generates a schedule model with planned dates for completing project activities. The key inputs are the schedule management plan, activity list, activity attributes, project schedule network diagrams, activity resource requirements, resource calendars, and activity duration estimates. You will notice that all of these are from the prior processes in this knowledge area, and we already reviewed them. So let's take a look at some key tools and techniques here. Critical path method involves calculating the theoretical early start and early finish dates, and late start and late finish dates for all schedule activities. We do a forward pass to determine early dates, followed by a backward pass to determine late dates. Let's look at a quick example here. In this example, the longest path includes activities A, C, and D. Therefore, the sequence of A, C, D is the critical path. The critical path is a sequence of activities that represents the longest path through a project, which determines the shortest possible project duration. The critical path always has a zero total float because any delay on that path will most likely result in a project finish delay. So we see then that there is no schedule flexibility. Also, any activity on the critical path is called a critical path activity. Critical chain method is a schedule method that allows the project team to place buffers on any project schedule path to account for the limited resources and project uncertainties that could affect the project schedule. For example, you realize that the building designs must be approved by a particular architect who may not be available as planned. Since this activity is on the critical path, you decide to modify the schedule by adding buffers at the end of your project to account for this in order to protect the target end date. Resource optimization techniques can be used to adjust the schedule model due to demand and supply of resources. Examples of resource optimization techniques include resource leveling and resource smoothing. Resource leveling is a technique in which the start and end dates of activities are adjusted so that supply and demand of resources is balanced. The supply of resources may be limited due to time or quantity, overallocation, or there may be a need to schedule them at a constant level. Leveling resources typically results in a longer critical path, so it's important to allocate scarce resources to critical path activities first in order to minimize the impact to the project schedule. Here is an example of resource leveling, and it shows a before and after scenario. You can see from this visual that Sue has been allocated to 2 activities during the same time period, so we can use resource leveling to keep resource usage at a more constant level and balance the demand for the resources with the available supply. In the second scenario below, Sue is now going to work on activity B on day 2, and Tom will work on activity C on day 3. Resource smoothing is a technique that adjusts the activities of a schedule so that resource requirements do not exceed resource limits. With resource smoothing, activities may only be delayed by as much as their float durations, so the critical path, and in turn the project's end date, is not affected. Modeling techniques. Let me cover 2 types of modeling techniques here. The first is a what-if scenario analysis, which is the process of evaluating scenarios in order to predict their effect, positively or negatively, on project objectives. We ask, what if the situation represented by scenario X happens? The outcome of the what-if scenario analysis can be used to assess the feasibility of the project schedule under adverse conditions and in preparing contingency and response plans to overcome or mitigate the impact of unexpected situations. Simulations involve calculating multiple project durations with different sets of activity assumptions using probability distributions constructed from the 3-point estimates to account for uncertainty. The most common technique is Monte Carlo analysis, in which a distribution of possible activity durations is defined for each activity and used to calculate a distribution of possible outcomes for the total project. Schedule compression is also a tool and technique here used to shorten the schedule duration without reducing the project scope in order to meet schedule constraints, impose dates, or other schedule objectives. There are two types of schedule compression techniques. Crashing means adding more resources. However, this may increase costs and risk. Fast tracking means doing things in parallel that would normally be done in sequence. However, this increases risk, such as rework. The key output of this process is the schedule baseline, which is the approved version of a schedule model that can be changed only through formal change control procedures and is used as a basis for comparison to actual results. It is accepted and approved by the appropriate stakeholders as the schedule baseline with baseline start dates and baseline finish dates. During monitoring and controlling, the approved baseline dates are compared to the actual start and finish dates to determine whether variances have occurred. The schedule baseline is a component of the project management plan.